Yes, very good.
So,
Thank you.
floor is yours.
Thanks, everyone. So my name is Syamak. Everybody calls me Sia. It's easier. So if you want to, come to me and have a conversation, you can easily call me Sia. I am from a company called Accelerate AI. I'm a business development director. And I'll give you a brief overview who Accelerate is. But today I'd actually like to talk more about how Edge AI is transforming the industry. So I give you some real life examples we have done with customers, partners. So who is Accelerate AI? Founded in 2021, so almost 5 years old. In late July, we will celebrate our 5-year existence. Quite successful. A lot of funding by now, $450 million. We have about 250 employees, 60 plus of them are PhD, so highly engineering focused company. Today we have taped out 2 chips. I have some examples here. The Metis, which is already in mass production. And later this year you'll have the Europa chip, which is more for high performance computing. So the idea was to start at the super edge and then move slowly up the stack to high performance and then data center. So just to give you an idea how we have been focusing on our roadmap. Technology is based on digital in-memory compute. We can talk about that a bit later. And then there's also RISC-V controller use. So at the heart of the company, we want it to be open source. So hence the RISC-V choice. There is a lot of products already in the market. I can go through that later. We have a lot of well-known customers, but a few that are already, let's say, in production and testing. Or amongst of them are ESA or some let's say larger prime contractors or also in defense. So yeah, investors are actually all over Europe. It's a European at heart company because we believe that Europe needs to have its own infrastructure. Maybe it was relevant in 2021, but now it's definitely relevant to have AI infrastructure built by Europe, but for the globe. Why do we exist? I mean, it's kind of clear. Everybody knows GPUs are great for training data, but when it comes to inferencing, you can actually do it much better, much faster. There are many examples. Could be neuromorphic we just discussed. Could be any other example, but you don't need to use GPUs for AI inferencing. And since AI inferencing is the next big wave of AI, after all these data that is being trained, this is the area to focus on, right? So what the market is asking for is higher performance for a better price and less power hungry, right? We don't want to go and build nuclear plants just to run AI. As I mentioned, digital in-memory compute. I think you guys are all much smarter than I am, but this is basically just to overcome the von Neumann's bottleneck of compute going to memory and back and forth. We do that in parallel. So I think this technology exists since the 60s, but now really implemented well on chip level. As I discussed, there is this roadmap, and we are on track. It's quite, I would say, an ambitious goal, but we are on track, so that's good. The 2 taped out chips today are the Metis, as I mentioned, in Europa. You can see here some numbers. I mean, it's marketing right, 214 or 630. It always depends on your model. What are you running? Are you running generative AI? Are you running convolutional neural networks? So it depends on what you're running, but generally it's much faster than an average GPU and much cheaper in usage, but also in, I would say, capital expenditure. So what we do is we have the chips, we have the systems and the cards, and we have a SDK, software development toolkit. Obviously, when you have a trained model, you want to make sure that it's quantized, it's compiled, and therefore you need the software development toolkit, which is for free. You can just go download it on GitHub and start playing. So that was a bit about the company. Let me see how much time I have. Okay. The industries that we are already active in are basically everywhere. But if you look at the fastest growing ones, I have summed them here. And if you ask me what is the top 3, to my own surprise, obviously you have these two, so security, surveillance, transportation, logistics. Agri-tech is growing really hard, retail the same, and in Europe the fastest growing segment for us now is defense and aerospace, obviously because of the situation we are in today. Okay, so now I'll go back to how is it changing the lives of people around us. I'll keep it close to home. A company called Okuma, which we work together with. A year ago, they came to me and they said, "Hey, we are building a smart AI system to assist lifeguards in swimming pools." And I'm like, "Okay, so how do you want to achieve this?" They did already a pilot of 2 swimming pools. So what they do is basically they look with cameras, look at the swimming pools, about 18 of them, 4K cameras. And they can actually see if someone is drowning or not. If someone is playing or drowning, they train that model in that such way. And the lifeguard in the pool has a smartwatch that can get an alarm if something is wrong. And the way they used to do it is to, send all those images back to the AWS instance that they were running. And he told me that for the 2 swimming pools he were piloting, he's paying 5,000 euros every week. Just because he had to process all those images, these are big images, and he said, "I can't handle this cost, and I'm going to go to 15 and then to over 100 pools soon." So that's where the Edge AI solution came into play. So we sat down together, we run their model. So now what we have done is we have a server, an Edge server with 2 PCIe cards, and all the cameras through a switch connected to the server. Server is, I think, about 5,000, 6,000 euros, including the cards. And that's it. Now he just sends metadata back to AWS, barely any costs, and every pool is now equipped with these. We have already done 15 swimming pools in the Netherlands. Another 100 is now being planned to be installed. And already they're looking at how to support this in open water. So there's requests coming from like Abu Dhabi and those places to have also drones look around if people are drowning or not. So that's one example of how we change it. There is an article and great, conclusion made from a newspaper called Telegraaf. I mean, you are all smart people, so nobody reads the Telegraaf here, I hope. But you can find it online. Just check it out. It's fun. Second one is also close to home, but this one is in Belgium. They had another thing. They didn't use AI before, but this is food processing. So you see in agri-tech there will be not only, let's say, on the fields itself, but once the food is collected, the processing of that food is now also heavily relying on using AI to be much more efficient. And in this case, it was a potato sorting company. We did this with a company called Vintech. And we also worked with Ultralytics, who's building several YOLO models. OnLogic was the hardware provider. You can see a small picture here, but this is a fanless system. They used to work with NVIDIA, but they couldn't anymore because the NVIDIA system needed fans, right? And in this harsh environment of high temperatures, you really need a fanless system. Similarly, it goes into other industries, defense or healthcare. So what we did is that we have the computer next to the machine, and it can sort out the best potatoes and also kick out all of the stones it will encounter. And here the request was, okay, I need to run multiple things. I need to run the YOLO model. I need 250 frames per second, and I need about 7 millisecond latency. So because the conveyor belt is moving really fast. So with a little bit of tweaking, everything worked. Now they're scaling into all over Belgium where they do potato sorting. And maybe another thing that was important for them is to also run an operating system called Balena operating system for edge computing. That's important because they can remotely manage the device and they don't have to send anyone to manage the devices. And again, NVIDIA didn't support that. So that's another reason why they chose for Accelera. So 2 examples here near the Netherlands and Belgium. So next time you're in Belgium, you're eating potatoes, it might have been sorted by an Accelera AI machine. There's a lot more to go and give you an examples, but Smart city surveillance. I can skip this, but you all know, like all the cameras you see, there more and more police departments. Everybody's interested in how to do convolutional neural networks. We have defense, aerospace. We as Accelera, we mainly only work with the European companies for defense because, again, this is just something that was requested to us from the European Union, and we started since last year April. Before that, nobody wanted to be in defense, but now we are. But that's just because the market is requesting it, because everybody was working with Raspberry Pis and everything. At some point, if you're really developing sophisticated solutions, Raspberry Pi remains a development kit. You want to have a solid product that can, scale. What do we do there? Oh, sorry, let me go back. So what do we do there? There's a lot of things, right? Defensive drones, counter drones. There is even these days container ships with servers going to the battlefield that have generative AI running models. Retail, well, we all know the Albertines and everyone, they have self-checkout systems. Soon, a lot of them will have an edge device in their checkout systems to prevent what they call the loss prevention. So it's a nice word of stealing, I guess, but loss prevention. But there's also a lot of things like shelf monitoring. Again, a lot around computer vision, because generative AI at the edge is growing slowly, but it's very much in the piloting phase. Another industry you might think of, agri-tech, as I mentioned, right? This is, I give you just an example, but there is much more, right? Also, drones are used there for agri-tech. So, precision spraying is another big one. Precision spraying is quite big, actually, because they use robotics. And then robotics itself, right? So, healthcare robotics, agricultural robotics, as I discussed, inspection. Many of them eventually need to run their models at the edge in the robot itself. And so, yeah, that's basically a bit of my presentation. If you're interested, you can always get some hardware on the store. The GitHub page is here as well, and then there's a community that you can be part of, and it's good to have smart guys like yourself to be part of the community, build cool stuff. So, and if you have questions, feel free to reach out. Thank you.
Questions? Or yeah, maybe one. Maybe if there are any questions.
There's a question there. Shout.
Thank you very much for the presentation.
Sure.
I have one question regarding training, because everything that you showed us is mainly for inference.
Yes.
And I was wondering whether Accelera also target training or maybe in the future.
No, the whole architecture is built for inference. Training, you have Cerebrus these days. There's other people going after that NVIDIA business.
Still NVIDIA, still CPUs.
Let them have it. Let them have it.
Let me rephrase. There is no business for learning at the edge.
Not for our chips, no. No, the business is there from others, but not our chip. Yeah.
I can also shout. So I know nothing, not nothing, but very little about hardware. So I'm mostly a data analysis engineer, let's say. So how well this will work if I just write my Python code and burn into your chip?
Python works fine, is the best. But if you want to do faster, you can go a bit lower. C++ is better. But Python always works, for sure. Yeah.
Maybe one last question.
Maybe one last question.
Oh.
Hi.
Yeah.
When you mentioned data privacy with the, I think, surveillance camera systems.
Yes.
When you say data privacy, that means the recording never leaves the local infrastructure, or it means it's never been stored at all?
The image will only be used at the processing level. Once that's done, the metadata, which is metadata, is sent to the cloud system, and the picture is after that erased. Yeah. Yeah.
But the video stream goes over the GSM GPRS network to the watch, so it goes somewhere.
Oh, that you mean? Yeah, yeah.
KPN, travels the entire network before it gets to the watch.